Right, now let us see about phosphoric acid fuel cell. So this is PAFCs. It uses liquid phosphoric acid as an electrolyte, and they were the first fuel cells to be commercialized, developed in the mid 1960s and field tested since the 1970s. They have improved significantly in stability, performance and cost. And the characteristics have made the phosphoric acid fuel cell a good candidate for early stationary applications. And the electrolyte is a liquid. Evaporation and migration have to be carefully monitored and controlled. So this is very important. Okay, since it is a liquid electrolyte, its evaporation and migration are possible and they have to be carefully monitored as well as controlled. So since the electrolyte is highly concentrated or pure liquid phosphoric acid saturated in a silicon carbide matrix, and the operating range of temperature is about 150 to 210 degrees centigrade. The electrodes are made of carbon paper coated with a finely dispersed platinum catalyst. And if you see here, there is fuel in from upwards and from downwards we have excess fuel out towards the anode side, and towards the cathode side air input is there from upwards, and unused air, water as well as heat will be coming out from downwards. And the electrolyte will be having flow of hydrogen ions, and electrons are moving from above from anode to cathode, which provides the electrical current in the load, right? And at the anode, reaction is 2H2 gives rise to 4H plus ions and 4 electrons. Oxygen at cathode will be interacting with 4 hydrogen ions and 4 electrons, gives rise to 2 H2O, and overall cell reaction will be 2H2 plus O2 gives rise to 2 H2O, right? And the advantages of this particular fuel cell are they are operating at a range of 152 to 10 degrees centigrade, and the expelled water can be converted to steam for air and water heating since the temperature range is more. And PAFCs are CO2 tolerant, that is carbon dioxide tolerant, and can also tolerate carbon monoxide concentration of about 1.5%, which broadens the choice of fuels they can use. I told you that tolerance towards carbon dioxide as well as carbon monoxide is very important, because if they are not tolerant, they are going to reduce the performance and efficiency of the system, and they are much less sensitive to carbon monoxide than other types of fuel cells, that is proton exchange membrane fuel cell and alkaline fuel cell. These are the advantages. Coming to the disadvantages, the low power density and chemically aggressive electrolyte. Okay, so the low power density is one disadvantage of this particular fuel cell. Coming to the applications, these have been used for stationary power generators with output in the 100 kilowatt to 400 kilowatt range, and are also finding application in large vehicles such as buses. Okay, and major manufacturers of PAFC technology include Doosan Fuel Cell America and UTC Power as well as Fusey Electric. And India's DRDO has developed PAFC, that is phosphoric acid fuel cell based air independent propulsion, for integration into their Calvary class submarines. Okay, submarines mean the one which travel under the water. Okay, there these applications are there, right? This is all about phosphoric acid fuel cell.